Welcome students to the Magnet Lab. And so what we're going to be doing here is investigating the magnetic fields that are generated by several magnet shapes. We're going to do that in various ways. So to point out some of the shapes, we have a basic bar magnet. Let me flip him over so you can see that he's labeled on the south and on the north. We have horseshoe magnets, we have ring magnets, we have cylindrical magnets. And what's going to help us investigate the fields associated with those are iron filings, so we'll show that in just a few minutes, and compasses. Okay, so first thing we want to do is we want to establish which way is magnetic north and which way is magnetic south of the Earth. So pick a compass. I would choose one of the larger ones. And what you got to be careful with here is to keep all magnets as far away as possible from your source compass. And so we use him. And once we have what we believe is tracking the Earth's magnetic field with no other electronics close by or magnetic fields, once we're satisfied with that, then we see that the red tip, what that's doing is that's pointing toward magnetic north, and here we have magnetic south. We're going to want to take a bar magnet and set it along that line, far away though. Alright, so we're going to want to establish a line of sight far from there. So we're going to take our magnet, bar magnet which has south and north, and we're going to place him far away, but what we're going to want to do is keep the orientation like I'm showing you. Alright, so we know that this way is the north end of Earth's magnetic field. We're going to want to start with the south end of the bar magnet along that line. So far, far away, as best you can, establishing a straight line between those two. Now let's see what happens. Alright, so if I bring my horseshoe magnet, my compass close to south, we see that the red arrow is now pointing toward the south end of the bar magnet. But then I'm far away. We notice now that the Earth's magnetic field takes over. So as I'm close to the bar magnet, we see that toward north for the bar magnet is this way, this field dominates. Whereas I'm far, far away, magnetic north of the Earth is this way, he takes over. So what that must mean is that somewhere in between, there must be a neutral point where Earth's magnetic field is exactly balanced by the magnetic field of the magnet itself. So the way we try to find that, as we look in on the compass, is there's going to be a point at which those two kind of counterbalance one another. And that's when the needles will go pretty much sideways to one another. Alright, so it's at this point where we have a balance between, again, the north for the bar magnet and north for Earth's magnetic field. So what we can do is we can measure this distance, say from the south end of the bar magnet to the center or the edge, doesn't much matter as long as you're consistent. And so this will be known as our south neutral point distance, so with respect to the south end of the magnet. So we have a balance there. But we could also do something very similarly for the bar magnet if it were placed, let's say, on this end. So what we have now is, let's say we have our compass far away on the other side. Alright, so let's see what happens. So what we have is we have north, and then we come close to the bar magnet, and we see that the effect of the bar magnet takes over, and so that must mean that there's a point somewhere in between where the two kind of counterbalance one another. So you're going to have to kind of play and find where that point is. Or you get kind of an effect both ways. easier said than done. But once you get that point, then now what you have is another distance with which you can measure with a ruler from the north end to the compass itself. And so what we're looking for is a kind of a symmetry. Is this north neutral point, to what degree is it the same distance as the south neutral point that we had before? Now there are a couple other neutral points that you can investigate here, which if we take our magnet once again, but now we're going to change the orientation of it. We're now going to have magnetic north pointing toward true north, or Earth's magnetic field north. And what we can now do is we can investigate neutral points to both sides of the center of the magnet, known as east and west neutral points. And so once again, we ought to be able to find locations where the magnetic field of Earth and the compass kind of balance one another, as you see. So we can measure that distance, and this can be done in a couple of ways too, to the center or to the tips, one of the edges, and likewise on the other side. We should be able to find a neutral point roughly in there. Alright, and so that these neutral points on the east and west side should be pretty much balanced. Now, let's take you to another section. Or what we're going to do here is we're going to set up a platform. And we're going to take magnets of various types. And to give us a little more room, let's take our rulers and set them up. And so now we can take our magnet and we can place it underneath. And so we can get a global sense of what the magnetic field looks like by introducing iron filings. And so these iron filings, what we can do is we can sprinkle them over the magnet itself to try to get an overall pattern. This is a qualitative thing, to be sure. But with a little bit of practice, we ought to notice loops that follow along the magnetic field effect due to the magnet that's underneath. So you don't want to be too light, you don't want to be too heavy-handed, and so your options here are you can either sketch the pattern itself or take a picture with your smartphone and include that in your lab report. And so once we're satisfied that we've got a good enough overall pattern there, then we can go on and investigate another. So we want to get the iron filings back in, so we be careful to open the cap and create a little funnel. Pour everything back in. Alright. Then we try once again. Let me show you one more. So let's say instead of one bar magnet we had two, and let's put the south end and the north end close together to one another, and then let's see if we can get an idea of a pattern qualitatively that exists for those. So in this case, we're specifically interested in the interaction between the two, and I hope that's clear enough to see, is that we see loops which are connecting with one another, which indicates that they must have opposite poles to one another. And to give you an idea of that, we can kind of shift back and forth so you can see the moving patterns as they shift over the magnets. Alright, so that's what we're going to be doing for a few different magnet configurations there. Alright, so let's set that aside and let's show you one more idea here. Again, using our bar magnets. This time though, we're going to seek for a more qualitative approach. Alright, and so the way that we're going to do that is there's a template that's on your PowerPoint that you're going to draw around your particular bar magnet. So once you've got that, you're going to take your compass, and I would choose a compass of a smaller size. And what we're going to do is at various locations, if I just kind of do this quickly, hopefully you're noticing that the arrow is changing orientation as I move around the bar magnet. So you're going to be placing compasses at different locations. And so this will give us a better quantitative feel. I know this is more tedious to do, but this will show us the field at any particular location. So what you can do is make a little mark on each side and remove the compass and draw an arrow for north to south at various locations. And so in that way, you have, between a merger of using the iron filings to give you a qualitative feel and the compasses to give you quantitative feel, you can get a pretty good idea as to the overall pattern.